Today we're going to talk about how to properly set up your LCT comparison microscope so that we achieve color balance and intensity balance in the microscope. We're going to start out with the light source and move our way through the illumination ray path of the microscope, up through the viewing ray path, so that we are able to look at the whole system and make sure everything's set correctly. To start with, some of our fiber optic cables have a rotary orientation to them. So to achieve proper intensity balance, you want to take a look at your fiber optic cable. If you've got an alignment mark like this, you want to look for the corresponding alignment mark on your fiber optic light source and put those two so that they're in line with one another. When we come around to the back of the microscope, you're going to see that we have everything labeled right and left. In fact, the whole microscope is set up that way. In order to achieve proper color balance, we have had to hand sort the optics which are on the right side of the microscope and hand sort the optics that are on the left side of the microscope. By doing that, we can assure that we are able to achieve the color balance that's so important to you, and to maintain the integrity of that balance, we've got to keep those items that were located on the right side on the right microscope and on the left side on the left microscope. So once we know we've got everything on the right and the left, we're going to insert our fiber optic cables all the way into the collector lens back here, and then start moving forward through the illumination ray path. Some of your microscopes will have optional in-base filters. If we do have those optional in-base filters, they're controlled by small levers down here, and we're going to want to have them, all those filters, out of that ray path. Those aren't filters that we're going to use, so we just want to leave them out. You'll notice that we don't use any of the illumination controls from Olympus that are built into the microscope. Everything's controlled by the fiber optic light source that we have here in the back. Moving up through the ray path, what we're trying to do is get the right and the left microscopes set up identical to one another so that we know that we can achieve the color and intensity balance that we're looking for. Here's our field diaphragm. We're going to come back to that in just a minute. As we move up through here, if we have a polarizer that's removable, you're going to want to remove that from the ray path of the microscope by pushing it to the right. This is a special option that Leeds makes. Olympus leaves this polarizer permanently mounted if you don't have the Leeds option. If that's the case, we're going to want to make sure that both polarizers are oriented in the same direction. So if you can't remove your polarizer from the ray path, you're going to set the right and the left polarizer both at 0. Moving up from there, this particular condenser has a flip-out top element. Most of the LCTs we've built have this, but certainly some of them have a fixed top lens. In this case, we're going to flip that lens up on both sides of the microscope, and we're also going to make sure that our aperture diaphragm is all the way open. Once we achieve color balance and you're looking at your samples, if we need to close that aperture diaphragm back down, you're going to be able to do that. You're just going to want to close both the right and the left aperture about the same amount. With both of our polarizers out of the ray path, our aperture diaphragms wide open, and our top element flipped in, we're going to load 2 samples onto the microscope, one on the right stage, one on the left stage. I'm going to start out focusing on these with one of my low power objectives. I've got the right hair, in this case it's a dog hair, in focus on the right side. I now look at the left side image and bring that into focus as well. Now what I want to do is work my way up to my highest magnification, which in this case is 40x. I'm going to focus on the left side here, switch my light over, focus on the right. Now I've got the right side in focus at 40x and the left side in focus at 40x. And now what I want to do is achieve color illumination. And I'm going to start out by looking at the left side and closing my field diaphragm down all the way, and then using the condenser focus, I'm going to focus that until I see a nice sharp diaphragm. That's my field diaphragm. And then I'm going to do the same thing on the left side. Then what I'm going to do is I'm going to come back to a position that's 50-50. And the reason I do that, when you look at your field diaphragm, people have a discussion over where is in focus. It's hard to see just when the edge is in focus of that leaf diaphragm. But what you'll see is there's a small area where there's a little bit of confusion about exactly where focus is. And what I want to do is form an image that's half the right side field diaphragm, half of the left side field diaphragm, and then I want to focus them both so that the fringe color around the diaphragm is the same color. It can be a little bit blue, it can be a little bit orange. I just want them both set to the same position. Moving up from there then, now I've got my samples in focus, my condensers in focus, I've got my field diaphragm image that I can see, and I'm going to want to continue to move myself up through what is now the viewing ray path and make sure that any filters or compensators that are in the ray path of the microscope have been pulled out. The same thing with our analyzers. In this case, this microscope has polarized light, so I need to pull those analyzers out of the ray path as well. This one's also optioned with fluorescence, so we're going to want to turn to the open position in our fluorescence. In this case, the number 1 position is labeled as bright field, and so we've got none of those filters in our field of view. So now, when I come and I take a look at my 2 samples, moving up through there, I don't have any filters left. I come in and I should be able to open both of my field diaphragms wide open and have a color balanced image. Now, you say, what about all those other accessories? I want to be able to use those. We've gotten the microscope set up to its proper setting, and now you'll be able to bring each of those individual filters or techniques that we don't currently have active on the microscope. You're going to be able to bring those in, and as long as we bring the same accessories or filters in on the right side of the microscope as we do the left, then we should be able to maintain color balance while running through the various imaging techniques that we have. That's it for today. Thank you. So we're going to start focusing our right hand condenser first. I close down the field diaphragm, and then I focus until this is nice and crisp and sharp. And if it's not centered, I'm going to use the 2 centering keys to bring that image into the center of my field of view. Gonna open that up a little bit, and now we're going to switch to the left-hand microscope. And we're going to do the same thing here. We're going to close down that field diaphragm. And we're going to use our condenser focus to make it nice and sharp. And then we're going to center that one as well. Finally, what we're going to do is go to a 50-50 image here. And I'm going to focus both the right and the left condenser so that they have the same color around the edge of that diaphragm. That Abbey diffraction, if you will. Okay, so I got that one. You can see there's a little bit of a blue edge around it. I'm going to do the same thing on the other side. And now when both of them are opened up, we can see that our images are now color and intensity balanced.